one of the big points of AP is you can get data from a table and do something about it. Okay, so tabular data, or you can get something from an equation and do something about it, or you have graphical data and you do something about that. So just kind of be flexible with these types of questions. They'll either give you an equation, table data, or a graph, and then you got to analyze from those things. So for us, the smoothie store, oranges are being juiced at a rate modeled by this function, an exponential function over here. JT is measured at pounds per minute, T is in minutes, and then, so when it's being juiced at the same time, the store, wow, 400 pounds per minute. Oranges are coming in at a store at a constant rate of 400 pounds per minute. Like I said, after 2013, they kind of just gave up with the real world scenarios. I mean, this is a real world scenario, but man, what store comes in with 400 pounds per minute? Like, that's a lot of pounds. Yeah. Like, where are you? Like the Jamba Juice? I don't know where you guys are at. Okay. Anyway, whether it's realistic or not, we can still do the calculus. Calculate J prime of 2. You will not be doing this by hand. You guys tell me what to press right now. Let's press Y equals, and then, yeah, let's plug in our J of T. So 250, our E, we have to do our second natural log, and then 0.1x. Okay. Second quick. Yeah.
I have a stupid question.
Yeah, go ahead.
What is E?
E is, oh man. Wait, hold on.
Is it like a...
So that's where E comes from. Let's go back. Okay. What buttons to press to get the derivative? Math. 8. And you can just press the number 8. Okay. Tell me what to press. D over D. X. Good. And how do we get this one over here? Alpha trace. And we put that on Y1. And what is our X value? 2. Okay. And then 3 decimals truncate. 30.535 would be nice. Okay. So J prime of 2 is equal to 30.535. Again, I want to emphasize one more time, you do not have to tell College Board what buttons you're pressing on the calculator. This is calculator based. This is fine. They already know. Okay. This is the work you need to show. That's it. Okay. Well, the derivative is positive, so it has to be increasing. What's increasing? What is J? The rate of oranges being juiced. Okay? The rate of oranges being juiced is increasing at another rate. If you really need to, and you need to figure out the units, you can go ahead and put this over 1. So the units on the top over here is going to be pounds per minute. What is the denominator unit? Minutes. So this is going to be at a rate of 30.535 watt per what? A little bit more, pounds per squared minute. Pounds per squared minute. And we write that as minutes squared. Okay. Okay. Number 6. Are the number of pounds of oranges increasing or decreasing at t is equal to 2 minutes? Give a reason for your answer. Again, here is one of your rate in minus rate out, one of those problems. We have to incorporate these two in order to figure out at that certain time if it's going to be positive or negative. Okay. What is the rate of the oranges coming in? The rate in. 400 pounds per minute. So you don't have to put J of T or you don't have to put D of T. You can just put 400. And then on the side over here, I'll just put 400 pounds per minute. So because that's going to be constant. j of what? J of 2. We're definitely going to need to use a calculator over here, so it's going to be 400 minus, well, okay, so please be careful. Do I need the derivative function, or how do I get j of 2? Just alpha, yeah. So just alpha trace already. You don't need to find the derivative. This is the original function. Okay, so y of 2. And let's grab all of that. 305.3506895. Okay. Do not round any of your decimals until the very end. So when we do this, 400 minus 94.649 will be okay. Now we can make our two sentences. Are the number of pounds oranges increasing or decreasing? So we'll start with that. The number of pounds of oranges okay, we're going to put increasing because our derivative is positive. Because your rate in and rate out is increasing at t is equal to 2 minutes because 400 minus j of 2 is greater than 0, or 400 minus j of 2 is positive. Either one is totally fine. I'll just put one more sentence. The rate of incoming oranges or oranges coming in, any English equivalent will be okay. The rate of incoming oranges and again, you can be flexible with the second sentence. You can say the rate of incoming oranges is greater than the rate of oranges being juiced. You can also say the rate of oranges being juiced is less than the rate of incoming oranges. Either one is the same thing. Okay. Just like in English, make sure you are comparing apples to apples. I mean oranges to oranges, I guess, in this case. So make sure you're really writing rate and rate. Okay, you're comparing these two. You cannot just say the incoming oranges, because that's different. You have to say the rate of the incoming oranges, and then the rate of the oranges being juiced. Rate to rate. Okay. 2 more, and then I'm definitely done for today. Okay. Sorry, were there any questions on number 6? Any questions? Similar question. This time at t equals 10 minutes. You tell me what to write mathematically. Go ahead first, go. So you can do rate in, rate out. I'm not going to write that. Tell me what to write next. 400. And then I'll just put pounds per minute. Minus j of what? 10. Okay. Because this is calculator based, you do not have to actually put in this middle step. If you can already plug this in on the calculator and get the final answer, that's totally fine too. Okay, so you don't have to put this intermediate step. Let's go ahead and just plug in on the calculator 400 minus y1 of 10. 400 minus alpha trace y1 of 10. And that's fine. This is calculator based. It equals negative 279.570. And let's include the 0 because we need 3 decimal places. Negative 279.570. And it's going to be a very similar conclusion to number 6. And I'll meet you guys there. So I did make my second sentence a little bit flexible, but again, you could have said it another way. This time I just said it this way. The rate of oranges coming in is less than. You could have also put in your paper, the rate of oranges being juiced is greater than the rate of the incoming oranges. Okay, so just as long as you are comparing rate to rate. Like I said, these problems aren't a calculus yet. When we get into the integration parts, there's a couple of things that I cannot put in just yet, because usually these types of problems, they'll give you your starting pounds. Like, say for example, they'll give you like, at the opening of the store, there are 1,000 pounds of oranges already, so they'll give you that first. So right now it's kind of incomplete. We can only do what we can do right now based on your guys' skill and what I've taught. Okay, so we're going to revisit this one more time and do it with the integration. But this is all we can do. Let's do number 8. Is there a time t in between 3 and 6 now where the rate of the oranges being juiced is the same as the rate of the oranges coming into the store? Sometimes there is not, So let's go check the endpoints first, because if it's not, then we cannot say, we can't use intermediate value theorem. We just got to say we can't find one. So before we make any conclusions, let's actually do the endpoints first. So let's do 400 minus y1 of 3. Check that out. Okay, it's positive. And then if the 6 comes out to negative, then I think we can do intermediate value theorem. So 400 minus... Well, hopefully it's negative. I think it should be negative. Let's try. So yeah, negative 55 point. Okay. So there's a point in time where those two rates are going to be equal to each other. So what this means again is we're looking for, when we subtract rate in and rate out, they're going to equal to 0. So that's what we're trying to test. Okay, and we did test it because at the 3, it is positive, and then when we test the other endpoint 6, it now turned into negative. So somewhere in between, it's got to pass 0. Okay. All right, but we can't use the intermediate value theorem without stating continuity. Okay, how should we state continuity? Let's take a look at J of t. What do we know about exponential functions? Is it not continuous or is it continuous? They're continuous. Yeah, it's got a horizontal asymptote, but it doesn't have a vertical asymptote. Like, we can draw an exponential function without lifting our pen. Like that, J shape. So we can probably say something like, since J of t is an exponential function, .400 is a constant. It is a horizontal line. I guess if you really want to say that in the middle, you can. 400 is a constant. It's a horizontal line, and it's continuous. But it's not too needed. All numbers are continuous, real numbers. So hence, 400 minus J of t is continuous. Okay, we stated continuity. What should I write next for number 2? Yes. So starting with not just J of 3, 400 minus J of 3, and good thing that's already on the calculator. What was that? 3 decimals. 62.535. Good. Okay, we did the left endpoint. Now let's go ahead and do the right. And then on the calculator was negative 55.529. You don't have to write this, but again, just one more time. So there's definitely got to be some sort of value in the middle or it's going to pass 0. Okay. We can make our conclusion. Please be careful. Which one is our lowest value? Is it the one with the j of 3 or is it the one with the j of 6? So you got to write that first. Okay? So since 400 minus j of 6 is less than 0, less than 400 minus j of 3, and that's okay. Now you tell me what to write. Go. By the intermediate value theorem, yes, yeah. By the intermediate. Keep going. There exists a time t, I guess you guys could put c, does not matter, in between what two intervals? 3 and 6. Okay, make sure you do not put equals because we want it in between. And give me more. Sorry, did you say some words over here? Oh yeah, okay, yeah. Where 400 minus j of t is equal to 0. It's the same thing. Where I usually put such that, but it's the same.